Right, okay, so whenever we answer questions with SOHCAHTOA, we should always write down SOHCAHTOA. And we're looking at this triangle. I'm just going to remove that for a second. Now we're looking at this angle, 68, and this side here is the opposite. So we need to involve that. That's what we need to find. So we're definitely going to tick the O's for opposites. And we know this side here, that was that half square root 200. So what we're going to do is, just plug my computer in, is we're also going to use this length here. Now that's adjacent to the angle. That's the adjacent. So we're also going to use the adjacents. And the two ticks are above the TOA, so we're going to use the tangent. So we're going to use the tangent of the angle, which is 68 degrees, is the opposite of the adjacent. So we're going to get the tangent of 68 degrees, the opposite. Now that's the length that we're trying to find. So that's the length MV divided by the adjacent. Now that's the one that we found earlier, so that's half square root 200. So to find MV, we're going to multiply both sides by this denominator. So MV is a half square root 200 times the tangent of 68. So I'm just going to get the calculator up here. There we go. I'm going to make sure that this is set up to do degrees. It is, so that's okay. Your calculators are of course different. So I'm doing a half, 1/2, times the square root of 200, and then I'm going to multiply that by the tangent of 68 degrees. And I get an answer of 17.5015. That's going to be centimeters. Now notice I do quite a bit of accuracy here because it's not my final answer, an intermediate answer, so I'm going to use a good bit of accuracy. So now what I need to do, now that I've found, what's that diagram got? Strange, it sort of disappeared. 1 second. Ah, yes, here we go. So once I've found that, then I can go back to my volume formula. So my volume is 1/3 times the area of the base, which if you remember was 100, multiplied by my 17.5015. So if I keep that in the calculator as my answer, multiply that by 100 and then divide it by 3, which is the same as multiplying by a third, and I get 583. Uh, 0.4, that would be to one decimal place. You might want to say 583 to 3 significant figures or something like that. And the units, of course, are centimeters cubed. Next question. Question 28. Now this looks like a nasty question. It really isn't. It's just a substitution question. So starting off with y equals p times q to the power x minus 1. And it says when y equals 10, x equals 1. So I'm just going to substitute in y equals 10, x equals 1. So let's see what happens. So y is 10. We don't know what p is at the moment. Times, we don't know what q is at the moment, but we do know what x minus 1 is, because x is 1. So this is 1 minus 1. Quite a few people did that and then stopped. I'm a bit confused maybe 1 minus 1 here. So 10 equals p times q to the 1 minus 1 is 0. Remember, anything to the power 0 is 1. So we can say something like that q to the naught is 1. So therefore 10 equals p times 1, i.e. p equals 10. Now once we've calculated that p equals 10, we can then substitute in this information. So let's do that now. Let's go up here. So we're going to substitute in y equals 0.3125 equals p, and we already know that's 10, times q to the power of x minus 1. Well, x is 6, so this is 6 minus 1, which is 5. That's 5. So how do I work out q is? Well, first thing I need to do is divide both sides by 10. And then to find q, I'm going to find the fifth root of this. So q is the fifth root of 0.3125 over 10. Now, on your calculators, you've got a button that looks like the fifth root. It's sort of looks like that button, looks like that. I don't have this on this calculator, so I'm going to use the laws of indices. Now, if you remember what the laws of indices says, the fifth root is raising to the power 1/5. So I'm actually on my calculator going to work out what this is. So I've got 0.3125 divided by 10. Obviously, I could just shift the decimal point, and then I'm going to raise that to the power 1/2. Could put 0.5 in there if I wanted to, and I get an answer here of 0.17677. Okay, so Q is 0.176777. That's plenty of decimal places. So now I know what P and Q is. Now I can work out what the value of y is when x is 3. That's what they're asked to do now. So when x equals 3, y is the value of P, which is 10, times Q, which of course is this 0.176776, etc. I put 7 there, and I rounded it. Raised to the power of x minus 1. Well, x is 3 in this case, so 3 minus 1 is 2. So I need to square my current answer, and then I'm going to multiply that by 10. So I get y equals 9.7656 times 10 to the minus 3. Okay, that's what the calculator gives. And of course you could move the decimal point and have it as a decimal value if you wanted to. Obviously what it would be 9.7656. I'd need to move the decimal point 3 times. 1, 2, 3. So we get 0.00097656. Okay. Next question. Question 29. Here is the graph of y equals f of x. Now, it's a quadratic. It tells you it's a quadratic. It's an n-shaped quadratic. So actually, its coefficient of x squared is negative. These are the sorts of things that should come into your head. Remember, we've got y equals ax squared plus bx plus c. And a is negative for an n-shape, and a is positive for a u-shaped. We might need that, we might not. Let's see. Write down all of the integer solutions of f of x greater than or equal to 0. So remember, y is the same as f of x, so this y axis is the same as the f of x axis. And where does this f of x axis become greater than or equal to 0? Well, it's anywhere from here and upwards, or anywhere from the x-axis upwards, isn't it? This is where f of x is greater than or equal to 0. above the x-axis. So where is the curve defined so that it's above the x-axis? Well, it's anywhere from here all the way along the curve to there. So any of the values of x between here and here are the correct solutions. But we only want the integer solutions, the whole numbers. So that's going to be this one, this one, this one, this one, this one, and this one. So we're going to have minus 3, let's write that in the answer, minus 3, minus 2, minus 1, 0, 1, and 2. Question 30. We've got two functions, f of x and g of x. And it tells us to work out f of g of x. This is the composite function. It is not multiplication. Okay? You might prefer to read that as f of g of x, like that. So that's what we're trying to find. How do we do that? Well, we start off with the function in the middle and we replace that with what g of x actually is. Keep the f there, f of, and g of x, of course, is 6x squared plus 3. Now, remember what I told you about learning how to do these functions. We're going to try and remember how to describe these functions in words. Sorry, what's my place here? What's it called? There. The function, this is how you should read this, for example, okay? It says the function f takes in inputs x, so x is my input, and it returns, that's the equal sign, the input divided by 3 plus 4. Okay, so it takes my input, divides it by 3, and that's 4. What am I feeding in to my function? I'm feeding in this thing into my function f, this one here. So, if the input is x, it produces the x divided by 3, the input divided by 3 plus 4. So here, I want the input divided by 3, there's my input, divided by 3, and then add 4. Okay, it asks us to simplify and give our answer in this form here, which is a sort of a quadratic type expression. So let's do that. You should notice this numerator has got a common factor of 3. So we're going to end up with 2x squared plus 1. So here 3 2s are 6, 3 1s are 3. And then the 3 will cancel. Do not want to see you cancelling like this. You cannot cancel when there's a plus in between here. Only when there's multiplication. So that's why I can cancel here. This is fine, because this is 3 times this bracket. And there's a 3 here, so I can cancel those fine. I am not allowed to cancel either. Seems that I've accidentally deleted some text here. 3x squared 3. I am not either, am I allowed to cancel here? Because there's plus. I cannot cancel with that 6, with that 3 either. Do not do that. Seeing that too much. Take a common factor, then you can cancel. So what we're left with now is 2x squared plus 1 plus 4, which of course is 2x squared plus 5.